My name is Jonathan Hicks and we're completing the square. Now in this video I'm going to explain what completing the square is and how you do it. You might be wondering though why we need to complete the square, and watching this video you'll probably be thinking at the end, okay, that's all very good, but what's it for? There's two applications for completing the square. One is you can use completing the square to solve quadratic equations. So I've done another video on that. If you want to know how to do that, go and watch that video. The second application is you can use it to give you a much better understanding of a graph. So for a quadratic equation, it's going to be something involving an x squared, and when you draw the graph, you're typically going to get a U-shaped graph, and there's various properties in terms of where, for instance, the bottom of the U is that you can work out instantly once you've completed the square. So it's quite useful from that point of view. So I've done a separate video on that as well. If you want to know about the using completing the square with graphs, watch that video. But in this video I'm just going to show you how to actually complete the square, what that means. Alright, so I think the easiest way to do this is with an example. So I'll just show you how to do it on an example and then I'll explain why it works. So we're going to have x squared plus 6x plus 4. So this is quadratic. We know it's quadratic because the highest power of the variable x here is a squared. That makes it quadratic. So to complete the square, you are going to rearrange this into some bracket which is going to involve x, which is squared, and then there's going to be some other stuff on the end. That's what we mean by completing the square. We're trying to get something squared where all of the x things are sort of encapsulated into this one bracket. Because the problem with this at the moment is that you've got some x bits squared here and you've got some x bits here, and combining these together, or rather not being able to combine them together, causes you lots of problems. So what this method does is it allows you to combine the x bits all into one thing, which is then always going to be squared. Because of this squared, you can't get rid of the fact that there's a squared in there somewhere. So let me quickly explain how you do it, and then I'll explain, as I say, why it works. Essentially, to get your x squared bit, you stick an x here, and then you don't worry about the number bit on the end. You just look at the x bit, and whatever number you've got here, you halve it and stick it here. So because this is plus 6, I'm going to write plus 3. Yeah, positive 3 is half of positive 6. So that's how you work out what goes in this bracket. Now let me try and explain why and where that comes from. This at the moment is not actually equal to this. Because of the plus 4, there's some other things that we need to add on the end here, but I just want to show you what we've got so far. If I just take x plus 3 squared and sort of expand the brackets and work out what you get, I'll stick that over here. So x plus 3 squared, well that means you've got x plus 3 times another x plus 3. Yeah, these two brackets are multiplying each other. So we do the FOIL expansion, so you multiply the first things, x times x gives you x squared. You do the outside, which is the plus 3 times the x. The inside terms is another plus 3 times x. And in the last term from each bracket, the 3 times the 3 is going to give you a positive 9 in this case. Now don't worry about the numbers, but essentially what we're going to try and do is make this look like this. So again, we kind of forget about the numbers for the moment. We can fix that later. The numbers are quite easy to fix. But if we want to end up with x squared plus 6x, which is what this is going to give you, in order to get the 6x, it's always going to come about from two lots of this. Because when you expand the brackets, you're going to get one lot of 3x and another lot of 3x. So because you always end up with two lots of that, whatever you've got here, we want it to be 6x. That's why you need half of it in here. Because half of this, the 3, means you're going to get two lots of the 3x, which when you combine them together, will give you the 6x that we need. So far, constructing this in this way, so that I put x, and then whatever that is, half of it goes in there. When I expand this, I'm going to almost get that. I get the x squared bit that I need. I get the plus 6x bit that I need. The only problem is the plus 9 on the end is not the same as the number on the end there. So when I expand this, I'm going to get all of this, but I don't want this plus 9 on the end. So I get rid of the plus 9 by simply subtracting 9. So this now is the same as that. When I expand out the brackets here, I'm going to get the x squared plus 6x, and when I square that, yeah, the 3 times the 3 gave me the plus 9 on the end. So when I square that, I'm going to get a plus 9 out on the end, which I don't want, so I subtract 9, which means it disappears. So all of this just gives you that. But to make it the same as this thing here with the plus 4, I need to keep the plus 4 on the end. Now, it's a bit long-winded trying to explain how this works, but let me just quickly go over that again. In order to construct this, you always have some bracket squared. The first thing is always an x to give you the x squared here. The second thing is always half of the number next to the x term, because when you do the FOIL expansion, you're going to get 2 lots of that thing. So 2 lots of it need to combine to give you this, so that's why you pick half. You then think to yourself, what would I get when I square this number? And you subtract it off the end to cancel it away. Then you add on the plus 4, or whatever the number was here, you just stick it on the end. Yeah. The reason we have to subtract the 9, again, just to reiterate, is because when you do the FOIL expansion, you're going to end up with this number squared appearing on the end. We don't want that appearing on the end, so we just subtract it off to get rid of it. So this thing is the same as this thing. We then just do a little bit of simplifying. Minus 9 plus 4 will give you minus 5. So our final completed square form of this quadratic expression would be this. We say that we've completed the square because all of the x bits are now wrapped up in one place, and they always end up having to be in something, a bracket squared. So that's why it's completing the square. And as I say, this turned out to be quite useful either in graphical applications, or if you're trying to solve quadratic equations, you can do it this way. So that's how you do it. Let me just blast through a few more examples now, and you should get the hang of it. It's quite simple to do in practice. It just feels a bit strange. Right, so we'll get rid of that. I should say that the examples you can get harder examples of this. I've started with quite an easy example, but I'll gradually increase the difficulty as we go through the examples, so you'll see all the different kinds that you might potentially encounter. All right, next example then. So we'll have x squared minus 2x plus 7. So to complete the square, you need some brackets squared. Don't forget the squared, that's really important. X always goes here, not x squared, just x, because when you expand the bracket, you're going to get the x squared out of it. And whatever this, however many lots of x you've got here, you always halve that. So if I've got minus 2, then I put minus 1 here, because that's half of minus 2. Then I think to myself, when I expand the FOIL, do the FOIL expansion for the bracket squared here, I'm going to be squaring this minus 1, and that's going to pop out the end. So minus 1 squared would give me positive 1, which I don't want, so you subtract that off the end. You always subtract off the end whatever this thing is squared. And then whatever the number term is, you just stick that on the end. And the last thing to do is you collect these together and work out what you've got. So our final completed square form for this quadratic expression is x minus 1 squared plus 6, because minus 1 plus 7 is plus 6. Okay, fairly straightforward. Let me quickly expand this just to convince you that this really does give you this. It'll help you just to get your head around what's going on. So you don't normally need to do this. Normally you stop there, you've completed the square. But if we expand the brackets here, so it's going to be x minus 1 times x minus 1, and there's a plus 6 on the end. So x times x gives you x squared. Outside is minus 1 times x, which just gives you minus x. Inside is minus 1 times x, which also gives you minus x. Minus 1 times minus 1 gives you the plus 1, and the plus 6 goes on the end. Collect stuff together, you get x squared here. Minus x minus another x gives you minus 2 lots of x, and plus 1 plus 6 gives you plus 7. And you can see that this is exactly the same as this. So following through all the different bits there, I mean, if you want to work through it yourself, just hit pause, look at all the steps here. So you can see how I've worked this out. Yeah, you halve that number, subtract off whatever that is squared, remember to add that on, and then collect it together. And the reason it works when you expand it out, you can see where the bits come from. You can see that I'm going to get -2 here, I get 2 lots of the -1 that we put in the bracket. This +1 here comes about from squaring the -1s. It's -1 times -1, which gives you the +1. So that's where all the bits come from. All right, let's do another couple of examples. As I say, we'll make these a bit harder. So far they've all been whole numbers. You'll find quite a lot of the time when you're completing the square that you don't get whole numbers, which can make it harder. I mean, it just involves fractions. As long as you can add, subtract, multiply, divide fractions, you should be fine. So we'll have x squared plus 3x plus 3. So you need your brackets, which are going to be squared. To get the x squared, you stick an x here. Now to get this number here, you halve whatever you've got there. At the moment I've got +3, so you halve that. Now generally in maths you want to do things with fractions rather than decimals when you don't have whole numbers. So rather than writing 1.5 or something, if it's 3, you just do 3 divided by 2, gives you 3 over 2. Yeah, you don't actually need to work out what half of it is. If it's not a whole number, you just write whatever it is over 2. So it's easier to use fractions generally. Now, when we do the expansion of this, we're going to get that thing squared popping out the end, which we don't want. So we need to subtract off the end here, whatever 3 over 2 squared is. If you're squaring a fraction, you just square the top, square the bottom. So we need to subtract 9 over 4. Yeah, 3 squared is 9, 2 squared is 4. So we subtract 9 over 4. Don't forget to put your +3 on the end. And then we just work out what we've got. So it's -9/4 plus 3. Now if you're adding and subtracting with fractions, you want the same number on the bottom of the fraction. So I would convert this 3 into quarters. So I've got 3 whole ones in quarters. That's going to be 12 quarters. So -9/4 plus 12 quarters gives you a +3 quarters. Go and practice adding and subtracting fractions if that was too quick for you. Yep, you need to be confident with fractions. It makes a big difference when you're doing algebra. So that, oops, and I've missed off the squared there. That is the completed square form for this. So if you have an odd number here, you're always going to end up with fractions here. So just watch out for that. All right, last one then. There's one type of quadratic we haven't looked at so far, and that's where you have a number in front of the x squared. Now that can make it quite a lot more difficult. So I'll show you the method. You very rarely need to do this, I have to admit. So if you had 2x squared plus 8x plus 1, for example, then we've got a bit of a problem because of the 2. Now I'll show you the method here, but as I say, you probably won't need this. I'm just showing it here in case you come across it and you find you do need it, then you can come back and watch this and you'll see, that's how you deal with it. Don't worry about the +1 yet, we'll come back to the +1 later. You want to try and complete the square just on this bit, but you can't do it with a number in front of the x squared. So you have to separate out the 2 from everything else. You can factorise that bit. So I'm going to put a 2 here, and I'm going to use square brackets, because when we complete the square, that's going to give us round brackets, and I don't want you to get confused between the brackets. So if I take a 2 outside from here, whatever that number is, you basically take that outside. So you'll be left with the x squared by itself on the inside, which is what you need. Now this was plus 8x, so if I take the 2 out, it's going to become plus 4x. Don't try and include the +1 here. Yep. Just close your brackets there, leave the +1 on the outside. We'll come back to that later. So what I've done is I've turned this bit. When you complete the square, you're always looking at these bits. And I've basically got rid of the number in front of the x squared. It's outside the square brackets. So I can just complete the square on the bit inside the square brackets, and then I can work out what I've got. So completing the square on this, well, again, you're going to get x something squared. So the x here, when you square it, gives us the x squared. We halve that number, it's plus 4x, which is going to give us a plus 2 inside the bracket. And then whatever this number is squared, you have to subtract it off the end. 2 squared is 4, so we're going to be subtracting 4 off the end. The plus 1 that was here, we're not going to do anything with that, you just leave it there. Yeah, so I've taken the bit that was inside the square bracket here and I've completed the square on just that bit. The 2, the square brackets, the plus 1 haven't changed, just leave them where they are. Once you've managed to do that, you then multiply out the square brackets with your 2. So I'm going to get a 2 in front of the round brackets, like that. And then it's 2 times the minus 4, which gives us minus 8, with the plus 1 on the end. Again, be careful, this plus 1 is not inside the square bracket. You don't multiply the 2 by the plus 1. We've just left the plus 1 on the outside all the way down. Now I can work out what I've got here. So this won't change. Minus 7 plus 1, sorry, minus 8 plus 1 gives you minus 7. So the completed square version of this is this. Now it will always, whatever that number is that's in front of the x squared, will always appear outside your brackets for completing the square if you have a term in front of the x squared. But there are other ways of doing this, but I recommend you do it this way, that you just separate out whatever that number is first, complete the square on the bit on the inside, then multiply the numbers back in and see what you end up with. So that's how you deal with those when they got the numbers next to the x squared. But as I say, most of the time that doesn't happen and you won't need to complete the square with that kind of thing. Alright, so if you want to know how to use completing the square to solve a quadratic equation, you can obviously go and watch that video. Or if you want to understand how it works in terms of graphs, you can watch that video.